Good day, sir. This is my alternative quiz. I am April Juris Lendorio, a BSEM3. A overview and history of mine ventilation. So, a brief history of mine ventilation. Agricola was also well aware of the dangers of black damp, air that has suffered from a reduction in oxygen content. Miners are sometimes killed by the pestilential air that they breathe and of the explosive power of fire damp, a mixture of methane and air, likened to the fiery blast of a dragon's breath. So, si Agricola daw is well aware sa mga dangers sa mga mahitabo sa black damp. Ang air that has suffered sa reduction in oxygen content din, ang mga miners kuno sometimes mamatay tungod kuno sa mga pestilential air. So, John Buddle, 1773-1843, an eminent mining engineer in the north of England, produced two significant improvements. So, si John Buddle daw is duha ka significance. First is, nag-introduce just sa dam drifts, which bleed sufficient fresh air from the base of a downcast shaft to feed the furnace. The return air, laden with methane, bypassed the furnace. The products of combustion entering the aft-cast shaft from the furnace were too cool to ignite the methane, but still give a good chimney effect in the shaft. So, naghatagapon siya kuno ng gana na quality sa chimney na nag-effect sa shaft. Then, thus inducing airflow around the mine. Then, si Badal, ang iya ikaduha na innovation was panel or split ventilation. Amo nang iya ikaduha na innovation. Until that time, airflow sequentially through work areas, one after the other, continually increasing in maintained concentration. Badal originally divided the mine layout into ang gidivide niya ang layout sa discrete panels with intervening barrier pillars to counteract excessive floor behave. So, car diesel speeding is isa sa mga serious attempt was the steel plant mill invented in 1733. Si just as well known or kilaya karadyo na mining engineer, again in the north of England. This device relied upon a piece of plane being held against a rapidly revolving steel wheel. The latter was driven through a gear mechanism by a manually rotated handle. The complete device was strapped to the chest of a boy whose job was to produce a continuous shower of sparks in order to provide some illumination for the workplace of a miner. The instrument was deemed safer than a candle rather, but the light is produced was poor, intermittent daw, and still capable of igniting methane. A crisis of a point was reached in 1812 when a horrific explosion at Filling Gates killed 90 miners. So, as you can see in the left side, you will see a picture. So, the first arrow, which is the steel disc, and second is the flint. So, doon ko na ay 92 ka minero na namatay. With the help of local clergymen, a society was formed to look into ways of preventing such disaster. So, sa tabang kuno ni Sir Humphrey Davy, ang president sa Royal Society for Assistance in Developing a Safe Slum, siya kuno ni tabang sa mga tao na namatay. Davy visited John Buddle to learn more of conditions in the mines. As this was well before the days of electricity, he was limited to some form of flame lamp. Within a short period of experimentation, he found that the flame of burning methane would not readily pass through a closely woven wire mesh. The Davy lamp had arrived. So, ang reaction ko ni Buddle is best expressed na letter na sulat niya para kay Davy. So, this was Buddle reaction. I first tried eating this explosive mixture on the surface and then tuck it into the mine. It is impossible for me to express my feelings at the time when I first suspended the lamp in the mine and saw it red hot. I said to those around me, "We have at last subdued this monster." So the lamp grew red hot kuno niglo ang lamp. So because of the methane burning vigorously within it, yet the flames could not pass. Dili pa makapasa ang flames but through the wire mesh to ignite the surrounding fire dam. So si Davy Lambs is isa sa mga gintroduced into British mines, then spread to other countries. Nevertheless, in the absence of effective legislation, candles remain in widespread use through the 19th century because of the bitter light that they produce. So, next is the relationships between ventilation and other subsurface. So, first is the objectives of subsurface ventilation. The basic objective of an underground ventilation system is clear and simple. It is to provide airflows in the sufficient quantity and quality to dilute contaminants to safe concentration in all parts of the facility where personnel are required to work or travel. So, ang basic requirement ko no sa incorporated into mining law is into those countries that have such legislation is the matter in which quantity and quality daw. Si curriculum nag-define as varies from country to country depending upon their mining history, the pollutants of critical concern, the perceived dangers associated with those hazards, and the political and social structure of the country. The overall requirement is that all persons must be able to work and travel within an environment that is safe and which provides reasonable comfort. Next is factors that affect the underground environment. It is often the case that it becomes impracticable or impossible to contend with all environmental hazards by ventilation alone. For example, nag-increase ang temperature tungod sa cause sa compression of the air na nag-downcast ang shafts because sa kalayuman sa mines nag-result ng air na being too hot for personnel even before it enters the workings. No practical amount of increased airflow will solve that problem. So third is the integration of ventilation planning into overall system design. It has often been the case that the types, numbers, and sizes of machines, the required rate of mineral production, and questions of ground stability have dictated the layout of mine without initially taking the demands of ventilation into account. This will result in a ventilation system that may lack effectiveness and at best will be more expensive in both operating and capital costs than would otherwise have been the case. So common error has been to size shops that are appropriate for the hoisting duties but inadequate for the long-term ventilation requirement sa mga minero. Sa mine area rather. So B is the environmental control of the mine atmosphere. First is the purpose and importance. In the vacuum of outer space, human astronauts rely on the artificial atmosphere of a spacecraft for their life support system. So, kabalo majud ta, diba? Pag maato ta sa outer space, did majud nato sa isa sa mga astronaut na ang mga life support system. Malamang, og wala inana, diba? Malisod na. Base matigok pa, diba? While differing in a local emission, human miners are no less dependent on an artificial atmosphere to sustain them in underground mines where the air may be stagnant and contaminated. It is evident that both miners kuno ug ang astronauts confront a hostile environment and that both groups must nagdepende na kuno sa ventilation air conditioning system na nagsupply sa pag-adequate sa air for breathing. Under even normal circumstances, exhibition in the earth like exploration in space can be fraught with a variety of environmental problems and hazards. While ground support is an obvious and compelling need, the most vital aspect of the mine environment to control is the atmosphere of the workplace. Para kuno sa mga mining engineer, ventilation kuno is ang most versatile atmospheric control tool. It is the process related on the accomplished most environment control underground. Mine ventilation is essentially the application of the principle of fluid dynamics to the flow of air in mine openings. As the primary means of quantitative control, rather, ventilation is responsible kuno sa mga circulation of air both sa amount o direction throughout the mine. Isa sab kuno ini sa mga constituent processes of total mine air conditioning that is simultaneous control within prescribed limits of the quality, quantity, and temperature humidity of mine air. Second is control processes. To retrieve the function encompassed by total air condition are 1. Quality control, 2. Quantity control, and 3. Temperature humidity control of the atmosphere. So to accomplish these objectives, individual conditioning processes are employed in mining. So dapat nag-consist sila ng following. 1 is quality control, purifying air and removing contaminants. So A, gas control. So this is dapat na gas control is B-force and gaseous matter including radiation. B is dust control, particulate matter, and 2, quantity control is its regulating magnitude and direction of airflow. So A is ventilation, B auxiliary or phase ventilation, C local exhaust. And third is temperature humidity control. This is controlling the latent and sensible heat. So A, cooling, B, heating, C, humidification, D, dehumidification. So control processes may be applied individually daw or jointly. If the objective is total air condition of the mine, then ang tulo ka 3 goals must be met. Makuan ko na makita or makuha ba. And multiple processes may be applied simultaneously. Several processes can serve more than one function. For example, ventilation, the most common one in mining, so performs mainly quantity control but wala siya mag-serve also for quality control and temperature humidity control. So, second is control processes. In coping with atmospheric environmental hazard in mining, certain engineering principles are fundamental and applicable to control of any contaminant. This contaminant consists mainly of gases, dust, but include heat and humidity as well. In order of preference of their application, ang engineering control principle nag-consist of prevention or avoidance. Second is removal or elimination. Third is suppression or absorption. Fourth is containment or isolation. And last is dilution or reduction. For example, if quality control of the dust hazard is the objective, then kaning 5 kuno ka step na mag-evaluate as appropriate na mag-apply sa order given. Ang ventilation daw is a dilution measure may be the ultimate solution. So, but it should be employed in conjunction with prevention, removal, and suppression by water and containment by suitable closure of the source. So, third, coordination of mining and ventilation systems. Notwithstanding its criticality to the life support process, environmentally control in mines possess a paradox. It does in all industry. On the other hand, environmental control is essential to the preservation of human life and necessary for the conduct of underground operations. So, on the other hand, it is ancillary to the primary objective of mining, the production of ore, rock, or coal from a minor deposit. The paradox is that environmental control contributes nothing to production directly and yet makes the production cycle possible. As stated previously, ang duha kuno ka mas vital environmental control na nag-measure in mining, first is ventilation and air condition, and second is roof support and ground control. Ideally, they should be performed with minimum interference and cost to the production operation. Realistically, they are essential and must carry top priority in the entire mining system. So, there's a question, how is the dilemma resolved? So, The answer is that environmental control measures are auxiliary operations that are programmed into and performed as integral part of the production cycle. Thus, they receive the attention they must but are managed to optimize the productivity of the overall mining operation. So, four highly important developments in the last 3 decades, two technological and two non-technical are responsible. One is the high-speed electronic digital computer, permitting advanced solution to ventilation circuits and networks heretofore unsolvable. Two is the system approach which optimizes complex industrial operation, permitting personnel, materials, and methods to be coordinated in the most efficient way. Third is the extensive federal legislation, embodying a strict code of regulation to improve the safety kuno sa mga mining operations na nag-operate sa mining. Then fourth is the advent of social engineering, the applying of technology with full consideration of social, political, economic, and environmental consequences as well as the technical benefits. So last is the foundation of mine ventilation and air conditioning. So the foundation of the field of ventilation and air conditioning is nagdid kuno sa mga discipline daghan na disciplines without being identified solely with anyone. They apply basic concept of physical chemistry, thermodynamics, fluid mechanics, and mechanical design to control the physical, chemical, and thermal properties of air. Sa mga mining engineers, daw, in coping with a more specialized field of mine ventilation and air conditioning, further grew from their knowledge of mining methods and designing underground conditioning systems. They are more limited in their practice than mechanical engineers in dealing with industrial air conditioning. However, as just described, their major conduits for airflow must coincide with the openings driven in the rock of mining purposes. Understanding of mine ventilation and air conditioning thus requires a knowledge of mining technology as well basic science. So I have here the accuracy of calculation. So in mine ventilation and air conditioning calculations, it is a general rule to express numerical values to 3 or preferably for significant figures. Next is mathematical units. It is a reflection of the times and the complexities of social political technological change that this third edition retains the practice of employing both English and SI mathematical units daw and adapted in the second edition. So the first edition adheres strictly sa English units. Next is the mathematical symbols. Symbols are generally employed in scientific notation as well as those peculiar to the fields of air conditioning and mine ventilation have been standardized and adapted throughout this book. And lastly is the map symbols. In standardized symbols for fans and control devices are customarily employed in mine ventilation mapping and surveying. So that's all, sir. Thank you.